Welcome to this presentation on the integration of Autosys with Amazon S3. S3 is a powerful development and storage tool for the deployment of platforms across multiple environment types. For our purposes, we'll focus on the file storage capabilities. The Autosys S3 integration can automate file management processes against S3. The integration brings several key benefits to application architects that rely on S3 for their work. It makes it possible to centralize file management workload by delegating it to a platform dedicated to process management, making it far more user-friendly than the S3 console. We'll provide some technical insights so that the components are known and the deployment sequence is understood. We'll focus on the configuration of the agents and the design of the 8 job definitions, as well as their configuration parameters: upload, download, copy, create, update, generate, and delete. Finally, we'll run through a demo. Autosys plays a central role in orchestrating operations across multiple environments and synchronizes these processes with other operations like deployment managers. S3 does come with batch management capabilities, but they're limited. The integration does away with the console and other UIs. We configure S3 storage processes centrally in Autosys and then trigger, monitor, and supervise all in one place. S3 file operations can then be synchronized with all other environments routinely supported by Autosys, like applications, databases, and ERPs. If S3 provides native batching capabilities, the Autosys integration offers a far more expansive platform. File operations can be defined and stored as feature-rich jobs and boxes for presence checks, file stability monitoring, or bucket reporting across multiple buckets. Autosys broadens S3's basic functionality with regular expressions, notifications, variables, workflows, parallel processing, URL query parameters, and much more. Autosys proposes several job types: upload, download, copy, delete, existence check, create, generate, and delete files to, from, or in the S3 bucket. The Autosys integration proposes significant improvements over the S3 console UI. Autosys' user interface is more streamlined, more intuitive, and comes with an array of capabilities to supplement the basic functions of the S3 console. For example, in the area of authentication, we can store credentials or configure third-party SSO platforms. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all S3 workload with other types that should be natively integrated with S3. We can build sophisticated configurations involving S3 working alongside multiple applications, multiple database packages, system processes like backups and data consolidation, web services, and other on-premise workload. Let's look at the aspects of job submission that are common to all actions. The baseline sequence is fairly simple because all job definition properties are stored as plain old Java or POJO jobs. Target system properties are defined as J2EE parameters, the S3 instance REST API URL, bucket, file names, regex, URL query parameters, and so on. Let's look at the sequence of execution. We start with the 3 main components: Autosys, the system agent, and the target S3 system. The POJO job is submitted to the system agent by Autosys. The agent acknowledges receipt of the job and needs authentication. It posts an access token request using the credentials stored in the job's J2EE properties. For our purposes, we'll use a key and a key secret as stored in AWS. S3 sends the access token in JSON format. This token is needed for job submission. The agent acquires the token and in return submits the action-specific job on the cloud storage object, meaning the file. This is based on an HTTP method set by the action on the job. The job runs, the file action is performed based on the response by S3, and the status is sent back by the system agent to the scheduler. Remember, we have 8 different job types representing 8 file methods. For each of these, we have a specific HTTP method and response. Thankfully, these job templates share certain characteristics. We explain them next. The first job type grouping is what we would call action jobs, meaning basic actions performed against single files in a bucket. There are 4: upload or download a single file, copy, meaning duplicating a file inside the bucket, and finally delete a file. The methods and responses vary with the action. Unsurprisingly, the upload and copy jobs rely on the put request, delete on a delete request, and download uses gets. Autosys will use either the HTTP response code or body for the status. Then we have 4 job types that check for the presence or absence of a file in the buckets. 1. Exist, returns either true or false immediately and the job succeeds or fails. The other 3 are monitoring jobs. These are cyclical processes that look at file presence and behavior in the bucket. Cyclical monitoring is based on a user-defined time interval that starts when the job is executed and completes only when the condition is met. We have 3 types: create, update, and generates. When you start them, they loop until the condition is met. Create scans the bucket and completes when a file initially absent is created and meets the condition. Update does the same for existing files that are growing in size. Generate combines the two for situations where we don't know if the files exist or not. If the file does not exist, it applies the create methods. If the file does exist, it applies the update methods. In this slide, we focus on the monitoring of single files. We plan on monitoring for a single file with a hard string name, and so we use the file URL. Consequently, all 3 jobs use HTTP head requests. They scan URLs of files in the bucket using headers. We'll explore some of the parameters, like sleep interval and steady state, later in the video. Exist, create, update, and generate can also scan for multiple files based on regex. So if we're looking to satisfy the condition and allow the job to complete based on multiple files, we can use wildcards like .* and $? We perform a full GET request and use XML data produced by the request. Let's take a look at how to deploy the integration. First, make sure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a pack file instead. Next, download the plugin extension package from Marketplace. This package contains all the necessary elements. Unzip the package and extract the contents into a temporary directory. Navigate to the System Agent install directory. Stop the System Agents with the sybagent-s commands. Install the plugin extension with this command: plugin installer, and then the System Agent install directory, and then the path to the CFG file. Finally, restart the System Agents with the sybagent-a command. We start with an S3 download job in Autosys. Let's display it. Pojo jobs are Java-based. They have several sections containing parameters. The primary section, which contains the name, target host, and so forth. The Pojo section contains the method name, in this case, downloads. The J2EE parameters section contains the S3 properties needed by the download job. The S3 endpoint URL, the access key and key secret for authentication, the bucket we're downloading from, the file name, as well as owner, owner group, and file permissions. These parameters can set ownership and permissions on the file when it's downloaded. When the file is created locally, it will inherit those permissions. The syntax varies from Windows to Unix. On both platforms, you can set a local user and user group, say administrator on Windows, root on Unix, or someone else. For permissions, Unix uses a 3-character sticky bit format, say 77 for read, write, and executes, and they're applied uniformly to the user and the group. Windows uses the same system with the letters R, N or W, and or X for read, write, and executes. Intuitively, you should expect the necessary parameters for each action type job, delete, copy, upload, and download, to be in line with what the action needs. Copy will let you copy files across buckets. We have a split screen with Autosys on the left and S3 on the right. We force the execution of an upload job, which uploads a job called data.csv. We observe the results. Next, we discuss the monitor jobs. Note that this does not apply to exist. When you start an exist job, it will scan the bucket to see if the file is there and return an immediate true or false. This is not what we're talking about here. Instead, we discuss create, update, and generate, which are cyclical in nature. When they're started, they simply remain active until a condition is met, say the file is there, based on the file name. Create assumes the file does not exist. The job scans the bucket until the file is created. Update assumes the file does exist but is being updated. The implications are obvious. If we have a downstream box job dependent on a data file, we want to monitor the growth and relative stability of the file before we execute the downstream job, or we'll be processing based off of incomplete data. We generate when we're not sure if the file is present. If it isn't, generate applies the create methods. If it's there, it applies the update methods. Let's talk about the parameters. We'll start with those that apply to all 4 file presence jobs, shown here in dark blue. The parameters that apply only to the 3 monitoring jobs are shown in red. In all cases, we're looking at whether a file is in the buckets before we return true for the job to complete. You can apply a control on the file size. The file has to be a certain size before it can return true. We have a regex parameter, which can be set to false, which means the control will be on whatever hard string file name you have in the fields. But you can set it to a regular expression. The 4 file presence jobs scan a bucket for assets based on specific conditions. Let's use an example. We're looking for doc files with evolving file names, which entails a wildcard, to be part of a larger documentation publish job. They might be very old files with the simple doc extension, or docx, which entails a second wildcard. .* substitutes more than one character to search for many files, and $? Substitutes a single character for doc or docx. Regex requests retrieval of the names of all the files that match the expression, any file name of any length with the doc extension and a possible additional character at the end. We can also use URL query parameters. Let's build on the expression we have with the caveats. We're only looking for files that start with the word file, which means using the URL prefix. We can pass URL query parameters, in this case prefix equals file. You could even combine parameters with the ampersand symbol if you wanted to apply more than one query parameter. We show the S3 assets in the bucket that match the regular expression. We have a sorting strategy field. Remember that we're using regex, which works in conjunction with sorting. More than one file conceivably meets the condition. If 3 files meet the condition stated by regex, Autosys has to pick one to set the condition to true, and we want to make sure that we use the right one. Sorting allows us to do so. We have the option of setting ascending or descending priority on the file name, the size, or time at which it was added to the bucket. Let's continue with our example. The bucket contains 3 files, file 1, 2, and 3.txt. 2 is the smallest, 3 is the largest. Based on the file name in regex, file.star.txt, all 3 files meet the condition, but remember, only one can return true. We run the monitor job twice, first with alpha descending. The last file alphabetically, file 3.txt, is the one that returns true. We run the job again with size ascending. In this case, the smallest file, file 2.txt, is the one that returns true. Sleep interval and steady state do not apply to exist, since they operate the mechanics of the cyclical monitoring process. The sleep interval is a time interval in seconds. It defines the frequency of execution of the monitoring process while the job is active. If you set it to 60 seconds, Autosys will perform a check on the bucket once a minute. Steady state is a time value in seconds. It's particularly important for file transfer processes. The file may be there, but we have to make sure it's stable and not growing in size, or your downstream jobs will be working off of incomplete data.